If the J-36 engine is ultimately going to be switched from the WS-15 to a variable cycle engine, then what exactly is the purpose of building 4 prototypes all at once? This question has been raised with increasing frequency since the J-36's maiden flight was publicly revealed in late 2024. It is not only being discussed among military enthusiasts, but some foreign military media outlets have also begun shifting their focus from the aircraft's appearance to its propulsion system. On December 26, 2024, a local resident in Chengdu captured footage of an aircraft without a vertical stabilizer roaring past, escorted by a J-20S. The airframe number 36011 was clearly visible, and the photos and videos went viral within minutes. Military observers have tentatively dubbed it the J-36, based on this number. However, within the aviation community, the term maiden flight is actually a matter of debate. As early as around October 2021, satellite imagery of the Chengdu Aircraft Industry Group test airfield had already revealed a new aircraft, suspected to be a 6th-generation fighter. In other words, the public appearance in late 2024 was most likely not the J-36's true maiden flight, but rather a public debut after its technical status had stabilized sufficiently. This timeline is not unfamiliar. The J-10C and J-20 followed the same path back in the day. From the public maiden flight to the end of January 2026, the number of J-36 prototypes had reached 4. The first prototype made its maiden flight on December 26, 2024. The second took to the skies in Chengdu in late October 2025, featuring a redesigned air intake and angled thrust vectoring nozzles. The third conducted test flights on December 25, 2025, with the pitot tube removed from the nose, indicating that aerodynamic validation was largely complete. The fourth prototype completed test flights on January 30, 2026, featuring additional tail control surfaces for enhanced maneuverability. Producing 4 prototypes in 13 months is an exceptionally rare pace in global 6th-generation fighter development. The J-36 engaged afterburner during its second test flight, whereas the J-20 did not do so until 8 months after its maiden flight. This suggests that the J-36's technical readiness is far more advanced than the outside world had anticipated. Among all these developments, the engine has sparked the most curiosity among observers. Footage released in late 2024 showed that the first J-36 prototype had a relatively long tail section. However, later test flight photos of an improved version revealed a noticeably shorter tail. The reason for this change likely stems from the technical maturation process of the WS-15 engine. In July 2018, academician Liu Doxiang, an expert in aero propulsion, stated during a public lecture that the 4th-generation low bypass ratio aeroengine project was progressing smoothly and would be finalized within the next 3 to 5 years. This implies that around 2021, the WS-15 was still in the final stages of development. It is standard practice in the aviation industry to prioritize the most technically mature and stable engines for the maiden flight of a new aircraft model. In 2021, the only mature engine suitable for the J-36 was the WS-10 series. The British magazine Aviation Week also speculated at the time that the J-36, which was in the testing phase, was equipped with the upgraded WS-10C. The real turning point came in 2023. In December 2022, academician Liu Doxiang revealed that the WS-15 had already been installed on the J-20 for test flights. In 2023, photos of the J-20 undergoing test flights with a new engine, featuring a black exhaust nozzle, were leaked, and it was widely believed that this was the WS-15. The WS-15 is a 4th-generation low-bypass, high-thrust turbofan engine with a maximum thrust of 18.5 metric tons and a thrust-to-weight ratio exceeding 10, outperforming the F119 used by the F-22. Returning to the question of why the J-36's tail section is shorter, the WS-15 is more compact than the WS-10. While the WS-10 features a 3-stage fan and a 9-stage compressor, the WS-15 has a 3-stage fan and a 6-stage compressor, eliminating 3 stages of blades. With the engine length reduced, the tail naturally becomes shorter. However, this creates a new problem. A gap is left in the middle of the tail, which could adversely affect radar stealth performance. The designers must have been well aware of this. So why do it this way? The most reasonable explanation is that the WS-15 is not the J-36's final target engine, but rather a transitional solution. The plan is to first use a more powerful engine to fully understand the aircraft's performance limits and accelerate the test flight schedule, then perform the final integration once the true target engine is ready. For the J-36, The WS-15 is akin to the WS-10 for the J-20, both are threshold-level engines. Another key factor is fuel consumption. The WS-15 has a relatively low bypass ratio, similar to the F119 at around 0.3. A lower bypass ratio improves high-speed performance, but also increases cruise fuel consumption. For a platform like the J-36, which emphasizes long-range strike capabilities and an extended range, high fuel consumption means a reduced range. You cannot have both thrust and range. This is not the optimal solution. What truly enables the J-36 to undergo a complete transformation is the variable cycle engine, developed by the Institute of Engineering Thermophysics at the Chinese Academy of Sciences. This variable cycle engine features a 3-duct design and has successfully completed full-scale high-altitude bench tests. Test data shows that during high-altitude tests simulating Mach 4, the engine switched modes smoothly, with the transition taking less than 0.5 seconds. Compared to fourth-generation engines, fuel consumption is reduced by 37.5%, while specific thrust is increased by 47%. Based on estimates using the WS-15 as a reference, the maximum afterburner thrust of the variable cycle engine could reach approximately 22 metric tons. The advantage of the variable cycle engine lies in its ability to adjust to the most suitable equivalent bypass ratio for different flight conditions. During low-altitude, low-speed cruise, the bypass ratio is increased to save fuel. During high-altitude, high-speed combat, the bypass ratio is reduced or even switched to turbojet mode to maximize thrust. The WS-15 belongs to the fourth generation, while the variable cycle engine belongs to the fifth generation. This is a genuine generational leap. If the J-36 is equipped with this engine in the future, its range is expected to increase by 60% and its maximum speed is expected to reach Mach 4. Its combat radius could be extended from approximately 2,500 kilometers to around 4,000 kilometers. Several details support this assessment. Based on leaked structural designs, the variable cycle engine has a similar number of stages in length to the WS-10 series. This may explain why the J-36's tail design wasn't significantly modified after the engine upgrade. Space was reserved for a more compatible engine. Once the variable cycle engine is installed, the gap in the tail section will be perfectly filled. If we examine the evolutionary path from the WS-10 to the WS-15 and on to the variable cycle engine, the overall trajectory becomes clear. The WS-10 is the starting point, the WS-15 is the transitional phase, and the variable cycle engine is the ultimate destination. WS-15 technology is already sufficiently mature and reliable, making it entirely feasible for high-intensity test flights. Meanwhile, news that the variable cycle engine has completed high-altitude bench testing indicates that the J-36's ultimate heart is already on its way. China completed the full-scale validation of key technologies for the variable cycle engine as early as 2018, with final certification expected between 2026 and 2028. Looking back, the WS-10 entered the in-air test phase just 1 year after completing high-altitude bench testing, whereas the WS-15 took approximately 4 years. No one can say for certain how quickly the variable cycle engine will progress, but judging by the completeness of the test data, the time frame is rapidly narrowing. The progress of the J-36 test flights is itself validating this assessment. If the WS-15 is indeed not the final design, then every current prototype is accumulating data for the future fully developed version. Once the test flight program is largely complete and the variable cycle engine has finished all its testing procedures, the J-36 will truly reach its full potential, flying farther, faster, and with lower fuel consumption. From the WS-10, achieving self-reliance and control, to the WS-15 matching the performance of the F119, and now the variable cycle engine surpassing the XA100 in performance, every step is reshaping people's original perceptions of this field. Without the 30 years of development, at the Zhangyo High-Altitude Test Facility in Sichuan, none of the subsequent engines would have been possible. So the question returns to where we started: if the ultimate goal is truly the variable cycle engine, will the 4 current prototypes, equipped with the WS-15, still be considered the same model once the variable cycle engine is installed? Or does this mean that the J-36 we see today is actually far from its final form?